Next is reactivity series of metals. We have learned that some metals are chemically very reactive while others are less reactive or do not react at all. On the basis of reactivity of different metals with oxygen, water and acid as well as displacement reaction, the metals have been arranged in the decreasing order of reactivities. The arrangement of metal in the order of decreasing reactivity is called reactivity series or activity series of metals. The arrangement of an order of the most active metal is placed in the top, whereas the least reactive metal is placed at the bottom. This is the reactivity series of metal. Lithium, platinum is least reactive metal in reactivity series. Reasons for different reactivity. In the reactivity of metal, the basis of reactivity is the tendency of metal to lose its electrons. If a metal can lose electrons easily to form positive ion, it will react readily with other substances. Therefore, it will be a reactive metal. On the other hand, if a metal loses electron less readily to form a positive ion, it will react very slowly with other substances. Such a metal will be less reactive. For example, alkali metals such as sodium and potassium lose electrons very readily to form alkali metal ion, therefore they are very reactive. Now, how metals react with non-metals? Octet rule. Octet rule, it was given by G.N. Lewis and W. Cosell in 1960. According to octet rule, an atom whose outermost shell contains 8 electrons is stable. This rule, however, does not hold good in case of certain small atoms like helium, in which presence of 2 electrons in the outermost shell is considered to be the condition of stability. Examples of elements whose atoms have fully filled 8 electrons in their outermost shell. All noble gases contain 8 valence electrons except helium, which has 2 valence electrons are present, are stable. They do not usually form bonds with other elements. Now, concept of bond. Except the elements of group 18 of the periodic table, all the elements of the remaining group at normal temperature and pressure are not stable in their independent state. These elements form stable compound either by combining with other atoms or with their own atoms. When in gross electronic configuration of the elements there are 8 electrons present, then these elements do not take part in chemical reactions because atoms containing 8 electrons in the outermost shell are associated with extra stability and less energy. Two or more than two types of atoms mutually combine with each other to achieve stable configuration of 8 valence electrons. Attempt to achieve 8 electrons in the outermost orbit of an element is the reason behind its chemical reactivity or chemical bonding. To achieve stability by gaining or losing 8 electrons in their outermost shell. Now, ionic or electrovalent bond. This bond is formed by atoms of electropositive or electronegative element. This bond is formed by atoms of electronegative and electropositive element. Electropositive element lose electrons in chemical reaction and electronegative element gain electrons in chemical reaction. When an atom of electropositive element come in contact with that of electronegative element, then electropositive atom loses electron and become positively charged, while the electronegative atom gain electrons and become negatively charged. Electrostatic force of attraction works between the positively and negatively charged ion, due to which both ions are bonded with each other. As a result, chemical bond is produced between the ions. Electrostatic force of attraction works between the positively and negatively charged ions, due to which both ions are bonded together. As a result, chemical bond is formed between the forming ionic or electrovalent. Number of electrons donated or accepted by any element is called its electrovalency. Electrovalence. Suppose we take example Na, electronic configuration 281. It loses 1 electrons and form positively charged ion. Similarly, chlorine electronic configuration is 287. It gain 1 electrons and form negatively charged ion. Due to opposite charges of Na plus and Cl minus ions, they are bonded by electrostatic force of attraction to form a new compound NaCl. Electrovalency of both sodium and chlorine atoms is 1. For the formation of ionic bond, it is necessary that the ionization energy of electropositive element should be less and the electron affinity of the electronegative element should be high. Now, properties of ionic compounds. First, ionic compounds consist of ions. All ionic compounds consist of positively or negatively charged ions and not molecules. For example, sodium chloride consists of Na plus and Cl minus ions. Example, sodium chloride contains of Na plus or Cl minus ions. MgCl2 contains of Mg plus 2 and Cl minus ions. So they consist of ions, not molecules. Next is physical nature. Ionic compounds are solid and relatively hard due to strong electrostatic force of attraction between the ions of ionic compound. They are solid and generally hard due to strong force of attraction. Third one is crystal structure. X-ray studies have shown that the ionic compounds do not exist as simple single molecules as Na plus and Cl-. This is due to the fact that the forces of attraction are not restricted to single units, such as ions. Each ion is attracted to a large number of other ions. So one Na plus ion will not attract only by one Cl ion, but it can attract as many negative charges as it can. Similarly, the chloride ion will attract several Na plus ions. As a result, there is a regular arrangement of ions in 3D structure. Such regular arrangement is called lattice structure. There is a regular arrangement of ions in 3D structure, which is known as the stable lattice, called melting point and boiling point. Ionic compounds have high melting point and boiling point due to strong electrostatic force of attraction between them. Solubility. Ionic compounds are generally soluble in polar solvents like water. They are soluble in polar solvents, water, and insoluble in non-polar solvents. Sixth is brittle nature. Ionic compounds, on applying external force or pressure, are broken into small pieces. Such substances are known as brittle. Ionic electrical conductivity in any substance is due to the movement of free electron and ions. In metals, electrical conductivity is due to the free movement of valence electrons. An ionic compound exhibit electrical conductivity due to the movement of ions either in fused state or soluble state in polar solvent, but in solid state, due to strong electrostatic force of attraction, free ions are absent, so they are insulated in solids. They conduct electricity in fused state, but act as insulator in solid. Now next is occurrence of. All metals are present in the earth crust either in the form of free state or in the form of their compounds. Most abundant metal in earth crust is aluminium, and most abundant element was oxygen. Native or combined state of metal. Native state or free state. A metal is said to occur in free or native state when it is found in earth crust in the elementary or combined form. A metal is said to be in free or native state when it is found in element. The metals which are very unreactive lying at the bottom of the activity series are found in free. Now combined. A metal which is occur in combined state, it is found in nature in form of its compound, which occur in form of its compound. A metal which occur in form of its compound. Copper and silver are metals which occur in both these. Copper and silver are metals which occur in both combined state.